We parked humanity's most sensitive eye 1 million miles from Earth in the absolute silence. Its mission was to confirm our best theory on how the universe began. But James Webb did the exact opposite. It brought us not an answer, but a crisis. It found black holes reaching billions of solar masses in just 400 million years. At a physically impossible speed, it detected the chemical traces of old galaxies in galaxies that should have still been infants. But what was truly unsettling was that these findings suggested even the age of the universe might be wrong. Our best instrument is telling us that our most trusted equations are fundamentally flawed. If you're ready to face this unsettling truth, like and subscribe. Because the universe as we knew it is no more. We begin. We parked humanity's most sensitive eye, 1 million miles from Earth, in the absolute silence. Its mission was to confirm our best theory on how the universe began. But James Webb did the exact opposite. It brought us not an answer, but a crisis. It found black holes reaching billions of solar masses in just 400 million years, at a physically impossible speed. It detected the chemical traces of old galaxies, in galaxies that should have still been infants. But what was truly unsettling was that these findings suggested even the age of the universe might be wrong. Our best instrument is telling us that our most trusted equations are fundamentally flawed. If you are ready to face this unsettling truth, like and subscribe. Because of the universe as we knew it is no more. We begin. For years, cosmology had a foundational story. The universe was a baby. After the Big Bang, it was a hot, shapeless cloud of gas. And this gas, under the patient hand of gravity, slowly formed the first stars over hundreds of millions of years, and then tiny islands of galaxies, just like a city that starts from a single dirt road and grows over centuries. Scientists built the James Webb Telescope to confirm this story, to see that first dirt road and those small structures. But when Webb looked at that road, it didn't find foundations, it found skyscrapers, and in that moment, everything we knew was shaken. Because in that first image, there was something from the earliest moments of the universe, something that should not have been there. Scientists called this concept impossible galaxies. So what does that mean? It's like opening the history book of the universe and finding a complete mob-bound novel where the very first sentence should be. According to our models, galaxies in the first few 100 million years should have been small, scattered, and chaotic. But Webb found fully organized, bright, and massive structures, and these were not exceptions. The telescope looked at an area of the sky smaller than a grain of sand held at arm's length, and in that dark speck, it counted thousands of galaxies. Some of these galaxies were there when the universe had completed only 2% of its 13.8 billion year life. This is less than a blink of an eye on the cosmic timeline. This situation was so shocking that physicists like Allison Kirkpatrick, who had dedicated her career to building the old models, openly said they were having a crisis of faith. Because the data was clean, the telescope was working perfectly, and the equations no longer explained the universe. But how is this possible? How can Webb see so far, so clearly? The answer lies in the telescope itself being a time machine. Light travels at the ultimate speed limit of the universe, about 186,000 miles per second. So when you look far away, you're actually looking into the past. The light from the sun takes 8 minutes to reach you, so you see the sun as it was 8 minutes ago. Our nearest star system is about 4 light years away. When you see it, you're looking at how it was 4 years ago. Yet, Webb takes this scale to unbelievable levels. It is looking at galaxies that are 13 billion light years away from us. This means that when the light it sees left its source, neither the Earth nor the sun even existed. Moreover, this ancient light, during its billions of years of travel, is stretched by the expansion of the universe, just like a wave on a rubber band. The wavelength of light lengthens, leaves the visible spectrum, and transforms into infrared light, which the human eye cannot see. This is where Webb's genius comes into play. Its main mirror, about 21 feet wide, is coated with a thin layer of gold, the element that best reflects infrared light. Thanks to its tennis court-sized shield that protects it from the heat of the Sun and Earth, it operates in one of the coldest spots in the universe, so its own heat doesn't interfere with the signals. Webb had to shut down its own engine to hear the first whispers of the universe. But what it heard was not a whisper, it was a roar. So what was the intensity of this roar? This is where the numbers go completely insane. A paper published in early 2023 shook the entire world of cosmology. Researchers had found 6 massive galaxies that existed when the universe was only 500 to 700 million years old. One of them alone had roughly 10 times the number of stars in the Milky Way. It took our galaxy billions of years to accumulate that many stars. These objects, however, had accomplished the same feat in a fraction of the time. This is like going to a construction site and finding finished skyscrapers with people living in them, instead of a foundation, in just 1 week. For these galaxies to grow this big this early, they had to be producing stars at an incredible rate. Mature galaxies like the Milky Way produce 1 or 2 solar masses of stars per year. These early monsters found by Webb were producing thousands of solar masses of stars every year, and they were doing this non-stop from the very first moments of the universe. No known physical mechanism allows for this, because, when stars form, their radiation pushes away the surrounding gas, slowing down new star formation. This is a natural break. But these galaxies, instead of hitting the brakes, seem to have floored the accelerator. What we are seeing is not a simple anomaly. This is a rebellion against the fundamental laws of the universe's operation. We are faced with galaxies that matured much earlier than they should have. The technology we use to see these galaxies is bending time itself, and the growth rate of these galaxies is shattering all known braking mechanisms of physics. Each finding alone was enough to cause a crisis. But when they all came together, a much deeper and more disturbing picture emerged. The story we told about the birth of the universe is not just incomplete, it may be fundamentally wrong. So how did these galaxies achieve this impossible growth rate? Was there a secret mechanism feeding them? Or were the rules that started everything much different than we thought? Because scientists have a few ideas, and each one is more unsettling than the last. The first explanation is that the conditions at the very beginning of the universe were completely different from what we thought. Perhaps dark matter, which forms the invisible skeleton of the universe, was clustering much more densely and efficiently in the early times. This could have acted like a cosmic supercharger, pulling gas into galaxy factories much faster than normal. Another idea concerns the first stars themselves. These generations, known as population 3 stars, were theoretically so massive and hot that their lifespans were only a few million years. But when they died, they may have spread shockwaves that triggered new star formation around them. So, the process that normally slows down star formation might have had the opposite effect in those first moments. Both scenarios challenge the models. But there is something sitting at the center of these galaxies that even these explanations are not enough to explain. This is the untimely black holes problem. Almost every large galaxy has a supermassive black hole at its center. Sagittarius A star, at the center of our galaxy, the Milky Way, is about 4 million solar masses. This is a huge number. But it is a dwarf compared to what Webb found in the early universe. The telescope detected black holes that had reached hundreds of millions, even billions of solar masses before the universe was even 1 billion years old. This is a situation that completely shatters known physics, because a black hole grows by swallowing, and there is a speed limit to this feeding. This limit, called the Eddington limit, prevents the black hole's own brightness from pushing its food away. At this limit, a black hole of ordinary stellar mass would need to feed continuously and at maximum speed for almost 1 billion years to reach 1 billion solar masses. Yet, some black holes found by Webb had reached this mass when the universe was only 400 to 600 million years old. There wasn't enough time. It was mathematically impossible. This is like a human reaching the weight of an adult elephant just a few months after birth. Physicists are now discussing radical ideas like direct collapse, where a giant gas cloud collapses directly into a black hole, without ever forming a star. This would give them a huge head start in the growth race. But even this idea is not enough to explain the number of these monsters Webb has found. They seem to be the rule, not the exception. But the problem is not just the size of the galaxies and black holes, it's also about the chemical elements they contain. This is the early enrichment paradox. The Big Bang produced only the lightest elements: hydrogen, helium, and a bit of lithium. Everything else on the periodic table, the iron in our blood, the calcium in our bones, the oxygen we breathe, had to be forged inside stars. This process takes time. A massive star must produce heavy elements, then explode as a supernova and scatter those elements into space. Then that enriched gas must form a new generation of stars. This cycle takes hundreds of millions of years at best. Yet, Webb found galaxies filled with heavy elements like oxygen and carbon when the universe was less than 1 billion years old. This means that multiple generations of stars had already been born, lived, and died within those galaxies. This entire cosmic genealogy was compressed into an impossibly short period of time. Astronomers measure a galaxy's chemical maturity by its metallicity. These baby galaxies found by Webb had metallicity levels of galaxies that should have been billions of years older. This completely upends the timeline. Either the first stars were element factories more efficient than we could ever imagine, or a chemical revolution that we do not understand occurred within those first few 100 million years. As you can see, everywhere Webb looks, the same pattern repeats. Too big, too fast, too early. Galaxies that formed much earlier than they should have. Inside those galaxies, black holes that grew much faster than they should have. And within all of this, heavy elements that appeared much earlier than they should have. These three major puzzles are now pushing scientists toward one unsettling conclusion. There may be a fundamental flaw in everything we understand about the first age of the universe. So, what picture emerges when we put these pieces together? Could so many anomalies actually be different reflections of one single, great chen unknown rule? And if so, what is that rule? And now comes the real shock. Because what we've described were not just theoretical problems, these were undeniable truths, transformed into data, seen by Webb's digital eyes. It is time to leave abstract concepts behind and look at the impossible objects the telescope found. Here are the discoveries that are keeping scientists awake at night. It all began in July 2022, that first deep field image. The scientists in NASA's control room were glued to the screen. There was silence, because what they saw was so much more than they expected. And as researchers began to zoom in on the image, someone noticed something. The galaxies standing right in the center of the frame, they were big, they were bright, they were fully formed, and they shouldn't have been there. Because the light from these galaxies had set out when the universe was only a few 100 million years old. That means just 2% of all cosmic history. According to the Standard Model, these galaxies should not have even begun to exist in that era. The model said that at that age, the universe would be filled with scattered, irregular, and dim proto-galaxies. But these galaxies looked as if they had been there for billions of years. That was the moment, the first major crack in a model built over decades. This was not a measurement error. It was not a simple anomaly. This was the universe's way of telling us, you were wrong. But that was only the beginning. The real bombshell dropped with a paper in early 2023. Even its title sent a shockwave through the entire field of cosmology. A team of astronomers had found 6 galaxies. Just bet. These were not ordinary galaxies. They all existed at the observable limit of the universe, when the cosmos was only 500 to 700 million years old, and the total mass of the stars within them was mind-boggling. One of them alone contained roughly 10 times the number of stars in the Milky Way. Think about that number. Our galaxy, the Milky Way, spent more than 13 billion years to gather its hundreds of billions of stars. This object did the same thing in less than 1/20th of that time. The lead researcher, Ivo Labbé, summarized the situation simply. Finding these galaxies was like doing a census and discovering that newborn babies have the same weight as adults. Physically, there was no way for a galaxy to get this big in such a short time. It was against the laws of thermodynamics. It was against the speed at which gravity works. And worst of all, these 6 galaxies were not alone. They were just the tip of the iceberg. Then the telescope looked even deeper, and things got even stranger. Because the problem wasn't just the galaxies themselves, it was the monsters hiding inside them. Webb began to detect quasars from the earliest times of the universe, supermassive black holes actively feeding. And one it found broke all records. A black hole that existed when the universe was less than 1 billion years old. Its mass, hundreds of millions of solar masses. That number means a mass capable of swallowing an entire galaxy on its own. These black holes were shining so brightly, they outshone their entire host galaxy, and this situation made the timing problem unsolvable. Because, for a black hole to reach this mass, even at the fastest known feeding limit, the Eddington limit, it would need to feed continuously for roughly 1 billion years. But these objects had reached this mass long before the universe reached that age. It was like the building being completed before the construction was finished. Either black holes were formed from already massive seeds when they were born, which is a mystery in itself, or they grew through some kind of hyperfeeding, a method that physics does not yet know. In either case, the first inhabitants of the universe were not playing by the rules, and as if all that weren't enough, there was the matter of the chemical signature. Oxygen, it shouldn't have been there. Carbon, it shouldn't have been there either. But Webb found plenty of these heavy elements inside galaxies that existed when the universe was less than 1 billion years old. Why is this a shock? Because glacistias. The Big Bang only created hydrogen and helium. Every other element is forged inside stars, then scattered into space when those stars explode as supernovae. This is the work of a generation, and it takes time, a lot of time. Finding high levels of oxygen in these galaxies meant that at least one, maybe more, entire life cycles of star generations had already been completed there. That is, stars were born, lived, died, and new generations were created from their ashes. All of this happened in that incredibly narrow time window at the very beginning of the universe. This is a timeline as impossible as a forest sprouting, growing, and then creating a new forest from its seeds in a single day. What we are seeing is no longer a single anomaly. It's a pattern, an epidemic. Galaxies that formed too early, black holes that grew too fast, and chemical elements that appeared too early. Each discovery is like a brick thrown at the wall of the standard model, and that wall is now starting to crack. So with so much evidence, what will scientists do? Could there be a single grand theory that explains this chain of impossibilities? Or is the universe much older than we think? And this question forced scientists to rethink the most fundamental structure of the universe, because the anomalies were not limited to individual objects. The massive structures that these objects formed together told the same impossible story. And now, we're moving to an even larger scale, because Webb began to map not only the galaxies, but also the cosmic web in which they live. And what it found there was perhaps the most disturbing of all. Here is the early cosmic web problem. The universe is not a soup of randomly distributed galaxies. It resembles a giant spider's web. The filaments of this web are made of dark matter, and gas flows along these filaments to form galaxy clusters at their intersections. According to the standard model, this web should have been much more tenuous, vague, and scattered in the early times, more like a rough sketch than a finished drawing. But, instead of the expected sketch, Webb found a nearly completed masterpiece. When the universe was less than 1 billion years old, it detected fully formed galaxy filaments stretching for hundreds of millions of light years. In some regions, there were even protoclusters, where dozens of galaxies were gathering, destined to become a giant galaxy cluster in the future. This meant that the dark matter forming the skeleton of the web was coming together much faster and more efficiently than models predicted. This was like the streets and buildings being completed before the city plan was even drawn. The architecture of the universe was billions of years ahead of schedule. But the story doesn't end there, because Webb's eyes noticed not only the very large, but also the very small and unexpected. And this is perhaps one of the most mysterious discoveries. They began to appear in the images. They were tiny, they were intensely bright, and they were undeniably red. Scientists gave them a simple name, little red dots, and after studying dozens of them, no one could fully explain what they were. Their redness indicated they were very far away from us. But they didn't look like a normal galaxy or a typical quasar. What made them really strange was their size. They were incredibly compact, but from this tiny volume, they were emitting enormous energy. No object that fits the standard model can produce so much energy in such a small space. The most popular theory is that these dots are a thick cocoon of dust surrounding a very active black hole. The black hole inside produces enormous energy. This energy heats the dust, and the dust re-emits this energy as red light. If this is true, it means we are seeing a previously unknown, hidden phase of black hole growth. But there is a problem. There are too many of them. If every little red dot is a feeding black hole, then the population of black holes in that era must be many times greater than what models predict. This is like finding a nuclear reactor in every house, unexpected and energetically difficult to explain. Some researchers are proposing something more radical. These dots could be a completely new class of object, something that physics has not yet even imagined. And then, Webb stopped looking at the farthest reaches of the universe and turned back to our own neighborhood. And what it found there was the most personal and perhaps the most hopeful act of this cosmic drama. K218b, a planet about 700 light-years from Earth. It orbits in its star's habitable zone, that perfect range where liquid water could exist on its surface. Webb studied this planet's atmosphere and not only confirmed the previously predicted water vapor, it also caught a faint signal of something else, dimethyl sulfide. Why is this molecule important? Because, on Earth, almost all of this gas is produced by living organisms, phytoplankton in the oceans. This could be a potential biosignature, chemical evidence of life. The signal is still very weak and needs to be confirmed. But that doesn't matter. What matters is that Webb proved it has the sensitivity to detect such a molecule in the atmosphere of a planet hundreds of light-years away. The telescope also found carbon dioxide in the atmospheres of the TRAPPIST-1 planets in another system. This is a giant step towards understanding the chemistry of those rocky worlds. Webb has moved the search for life from philosophy to science. It has opened a door. Passing through that door may be left to the next generation of telescopes. But we now know that door is not locked. As you can see, the picture is becoming more and more complex, from the largest structures of the universe to the most mysterious little dots, and even the atmospheres of neighboring planets. Wherever Webb looks, it finds an anomaly, a surprise. None of these findings alone may be enough to overthrow the standard model. But when they all come together, they create a weight that cannot be ignored. With so many inconsistencies in so many different areas, the question we must now ask is this: is there a single grand picture that brings all of this together? And what does that picture tell us about the telescope itself? Because without understanding how this incredible machine works, we can never grasp the true meaning of its findings. But all these shocking findings, these impossible objects, and broken theories are based on one fundamental question. How does Webb do it? What is the technology that allows it to see things so distant, so faint, so old? Because the telescope itself is an engineering marvel as revolutionary as its findings. Now it's time to put that fast pace aside and look under the hood of this incredible machine. Because understanding Webb's secrets is the first step to understanding the secrets of the universe. It all starts with a single basic principle: capturing infrared light. Imagine the oldest galaxies in the universe as candles. They were lit billions of years ago, but you are trying to look at that candle from billions of years away and through an ever-expanding fog. The light that reaches you from that candle is no longer the light you know. This journey consumes the light's energy, stretches its wavelength, and redshifts it. It redshifts it so much that the light completely leaves the visible spectrum and enters the infrared wavelength, which we feel as heat. This is Webb's playground. Older telescopes like Hubble worked primarily with visible light, like the human eye. But the first light of the universe was at a frequency where Hubble was almost blind. Webb, on the other hand, was designed precisely to see this frequency. Its main mirror is a giant structure of 18 hexagonal segments, a full 21 feet wide. This mirror is coated with an ultra-pure gold layer that reflects infrared light almost perfectly, with an efficiency of over 99%. This gives it both a huge light-gathering power and allows it to direct these ancient photons to its detectors without loss. This is why Webb can distinguish individual stars and galaxy structures in places where Hubble could only see a blurry smudge. It is an eye that sees the invisible colours of the universe, but looking with such a sensitive eye comes at a very high cost: heat. Infrared light is basically heat radiation. Therefore, if the telescope itself is warm, it will drown the faint signals from those distant galaxies it is trying to capture with its own heat. It's like trying to hear a whisper while a jet engine is running right next to you. Webb had to completely silence its own jet engine to hear that whisper. That is, it had to be incredibly cold. For this reason, Webb was parked in a special orbit about 1 million miles from Earth, at Lagrange Point 2, L2. At this point, the gravitational pull of the Sun, Earth, and Moon are balanced, allowing the telescope to remain stable with very little fuel. But the real engineering marvel is its massive sunshield. This 5-layer shield, each layer as thin as a human hair, is the size of a tennis court. While the side facing the Sun reaches scorching temperatures, it cools the shaded side where the telescope is to below -233 degrees Celsius. That is colder than the surface of Pluto. This extreme cold reduces the telescope's own thermal noise to almost zero. This allows it to cleanly detect even the incredibly weak signal created by those single photons that have been traveling for over 13 billion years. Each of Webb's images is not just an optical achievement, but also a thermodynamic triumph. So, after seeing so far and so clearly, how does it understand the chemistry of those objects? This is where a third magical mechanism comes into play: spectroscopy. When you take the light of an object, you don't just record it as a picture, you can pass that light through a prism and separate it into its colours, its wavelengths, just like a rainbow. This rainbow is called a spectrum, and a galaxy's spectrum is like its fingerprint. Because every element in a gaseous state absorbs light at specific wavelengths. So, when you look at a galaxy's spectrum, you see that certain colours are missing. Those missing colours, those dark lines, tell you which elements are inside that galaxy. On Webb, there are instruments like NearSpec that do this job with incredible precision. NearSpec can take the spectra of more than 100 different objects at the same time. This is a revolution that increases efficiency by hundreds of times. Older telescopes had to expose for hours to get the spectrum of a single galaxy. Webb, on the other hand, can produce the chemical breakdown of hundreds of galaxies in a deep field image in one go. This is why we know with such certainty that there is oxygen and carbon in those early galaxies. Because we saw in their spectra the unique, dark fingerprints left by those elements. Spectroscopy allows Webb to be not just a camera, but also a chemistry laboratory. When these three mechanisms, infrared vision, extreme cooling, and advanced spectroscopy, come together, a machine emerges that fundamentally changes the way we understand the universe. This is not just a bigger telescope. This is a completely new sensory organ for looking at the universe. It sees not just farthest abroad, but what was previously completely invisible. It hears not just more clearly, but the chemical song of what was previously silent. But Webb has another tool in its arsenal, perhaps the most mind-boggling of all, a trick that nature itself has offered it: the ability to use the universe itself as a telescope, and this trick will lead us to see even the oldest, faintest, single objects. And the name of this trick is gravitational lensing, predicted by Albert Einstein in 1915. This effect is based on one of the most fundamental rules of the universe: mass bends space-time. And as light travels through this curved space-time, its path is bent. You can think of it like a heavy bowling ball placed on a stretched sheet. The ball makes the sheet sag downwards. Now if you roll a marble across that sheet, the marble will not go in a straight line, but will curve around the depression created by the bowling ball. This is exactly what light does. When light from a very distant galaxy passes by a massive object, like a giant galaxy cluster standing between it and us, its path is bent by the cluster's gravity. The galaxy cluster acts like a giant magnifying glass created by nature. It both magnifies and distorts the light of that distant galaxy behind it, delivering it to us. This allows us to see objects that are too faint and distant to be seen otherwise. Webb has turned this technique into an art form. By using these natural magnifying glasses, it achieves a resolution that would otherwise be impossible. In one of its images, 3, 4, or even 5 different copies of the same distant galaxy may appear around the lensing cluster. Each copy is formed by light taking a different path. By combining these multiple images, scientists can reconstruct the true shape and internal structure of that background galaxy with incredible detail. It's like creating a 3-dimensional model from a single photograph. It is through this method that we have been able to distinguish the individual star-forming regions of a galaxy within the first billion years of the universe. This is something Hubble could never have achieved. Gravitational lensing gives Webb the power to reveal the deepest secrets of the universe. Because just as sometimes the biggest telescope is the universe itself, but Webb's capabilities are not limited to distant galaxies. It also has a unique equipment to look at much closer neighbours in our own galaxy, and the technique it uses here could be the key to the search for life. Transit spectroscopy. Imagine a planet passing in front of a distant star. As that planet passes in front of its star, it blocks a small fraction of the starlight. But if that planet has an atmosphere, some of the starlight will filter through that atmosphere and reach us. That is the moment the magic happens, because the gas molecules in that atmosphere, just like the elements in the galaxies we mentioned in the previous section, absorb light at specific wavelengths. So, when that light that passed through the atmosphere reaches us, it carries the chemical fingerprint of the atmosphere within it. What Webb does is compare the light that comes when the planet is passing in front of the star and when it is not. The difference is that tiny amount of light absorbed by the atmosphere. By analysing this difference, it can determine which molecules are in the atmosphere, water vapour, methane, carbon dioxide, even potential biosignatures. This is an incredibly delicate job. The signal created by a planet's atmosphere can be as little as 1/1,000,000th of the star's total light. It's like trying to hear a single person's whisper in a stadium full of people, all shouting at the same time. Webb's infrared sensitivity and stability made it the first telescope capable of hearing this whisper. Its capture of that faint signal of dimethyl sulfide on planet K218b proved how powerful this technique is. Webb has initiated the era of reading exoplanet atmospheres. We can now not only determine if a planet exists, but also analyse the air that planet breathes. This is one of the biggest steps taken towards answering the question, are we alone? As you can see, every one of Webb's findings is the product of an incredible technological and scientific mechanism behind it. It has infrared eyes to capture the oldest light of the universe. It works at a temperature close to absolute zero to protect that light from its own heat. It carries an advanced spectroscopy laboratory to understand the chemistry of what it sees, and to see the faintest objects. It uses the universe itself as a magnifying glass. When all these pieces come together, not just an observation tool, but an engine of discovery emerges, a machine designed to answer one question, but which instead created thousands of new ones. But all these technical details, these engineering marvels, bring us to the really exciting point. Equipped with these tools, Webb has come closer than any telescope before to one of the biggest and most fundamental mysteries of the universe, to an area where models have collapsed, theories have become insufficient, and the boundaries of science are being redrawn. What we have described so far were just individual discoveries, but next up is the great, unsettling inconsistency about the expansion of the universe itself, which all these discoveries point to. And this inconsistency could change everything. And now, we come to the moment where everything converges. All the techniques, all the engineering marvels we have described so far were just tools. Now it's time to see what those tools have found. Because the eyes. Webb turned to the edge of the universe didn't just find a few anomalies. They triggered a revolution. They created a cosmological earthquake. Get ready. Because the tempo is changing now. We are accelerating. What you've heard so far was just a whisper. Now you will hear the roar. Here are the moments that are shaking modern science to its foundations, rendering textbooks obsolete, and demolishing our most basic assumptions about the universe. This was not a galaxy. This was an impossibility. Its name is JADES-GS-Z-13-0. But that's just a code name. Its real meaning is this: one of the oldest, most distant galaxies ever seen. Its light travelled for more than 13.4 billion years to reach us. This means it shone when the universe was only 300 to 400 million years old after the Big Bang. This number is hard to grasp. So hard that if you condense the entire 13.8 billion year life of the universe into 1 year, this galaxy existed only in the first 3 days of the year, and it shouldn't have been there. The model said that in that era, there could only be gas clouds and perhaps the first stars. But this was not a gas cloud. This was a fully formed structure, home to hundreds of millions of stars. The standard model has a rule known as the mass accumulation limit. This rule draws the theoretical limit of how large a galaxy can be at a certain time. This galaxy, and dozens of others like it that were found, shattered that limit. Some of them had 10 times, or even more, mass than was theoretically possible in that era. This was like a truck ignoring the speed limit sign of physics and going at 100 times that speed. This single discovery instantly made decades of galaxy formation theory suspect, because the universe was not the slow and patient builder we thought it was. It was an architect who built empires overnight, and we were completely blind to this fact. But at the center of these empires, an even bigger monster was hiding, and this was a contradiction with time itself. Webb looked at the oldest quasars in the universe, that is, galaxies being viciously fed by the supermassive black holes at their centers, and what it found there was, in the truest sense of the word, unbelievable. Black holes that existed when the universe was less than 600 million years old, only 4% of its current age, and these black holes were not tiny. Some of them exceeded 1 billion solar masses. This is more than a number. This is a paradox. Because, even with the most efficient known growth model, a black hole needs at least 1 billion years to reach this mass. But the universe itself was not yet that old. The mathematics of time did not add up. This was as impossible as a 4-year-old child having 80 years of life experience. This discovery was so shocking that even the most radical theories, like direct collapse black holes, struggled to explain it. Because Webb didn't just find one of these monsters. It showed that they were surprisingly common in the early universe. This was not an exception, but a norm. In the early period of the universe, somehow, a mechanism that surpassed the laws of physics had created these gravitational monsters at a record speed. And we do not know what this mechanism is. This means there is a huge black hole in our most fundamental knowledge about the beginning of the A. And then, Webb shed light on the biggest crime scene in the universe, the Hubble tension. For years, it was the biggest and most embarrassing problem in cosmology. We have 2 main methods for measuring how fast the universe is expanding. The first measures by looking at the nearby universe, using standard candles like supernovae. The second looks at the cosmic microwave background, the oldest light left over from the Big Bang, and calculates the current expansion rate from the initial conditions of the universe. And for years, these 2 methods have stubbornly given different results. The difference was not a small rounding error, a full 8 to 10% discrepancy. Many scientists hoped this was due to measurement errors in older telescopes. They thought Webb's ultra-sensitive eyes would solve this problem. But Webb looked, and it did not solve the problem. It made it worse. Webb redid the measurements of the nearby universe with the highest precision in history, and it confirmed the results. The tension was real. It was not a measurement error. This was like a bomb exploding. Because this could mean one of 2 things. Either our understanding of the physics at the very beginning of the universe is fundamentally wrong, or there is a new component in the physics of the nearby universe that we do not know about. Webb destroyed a hope and replaced it with a much bigger crisis. Our most fundamental knowledge about the expansion of the universe was contradicting itself. And at the center of this contradiction lies the most mysterious and dominant force in the universe. Because this tension led us to the most epic and terrifying discovery: dark energy, the mysterious repulsive force that makes up 68% of the universe and accelerates its expansion. For decades, the standard model assumed that dark energy was a cosmological constant, that is, a constant force that never changes in time and space. It was a monotonous, unchanging note playing in the background of the universe. This simplified the equations. But in 2024, Webb's data was combined with data from other major surveys like DESI, and the result shook the world of cosmology. the data suggested that dark energy might not be constant. On the contrary, they presented the first serious statistical evidence that its strength might be changing over time. This is not just a technical detail. This is a discovery that rewrites the ultimate fate of the universe. Because if dark energy is weakening, gravity might one day win again and the universe could collapse in on itself. But if it is strengthening, then a much more terrifying end awaits us, the Big Rip. In this scenario, the expansion of the universe accelerates so much that it first tears apart galaxy clusters, then it tears apart the galaxies themselves, then star systems, planets, and finally individual atoms, ripping the very fabric of space-time. Webb did not remove this terrifying possibility from the table. On the contrary, by questioning our most basic assumption, it brought it to the forefront for the first time so seriously. So there you have it, the oldest galaxies in history. Black holes that grow faster than time itself, an expansion rate at war with itself, and a changing dark force that could tear everything down to its atoms. These 4 discoveries are not just puzzle pieces, this is the death notice of the old paradigm. So what is the meaning of all this chaos? Are these different crises actually different faces of one big, yet ununderstood picture? And what does this picture tell us about the fabric of the universe? And this picture tells us this about the larger scale architecture of the universe. The master plan is wrong. Because these anomalies found by Webb were coming together to form even larger, even more impossible structures, and this pointed to a much more fundamental problem than a single galaxy or black hole. This was about the moment of cosmic dawn itself, the moment the universe turned on its first lights, moving from darkness to light. Models predicted this transition to be a slow, gradual process that took hundreds of millions of years, like the slow breaking of a dawn. But Webb's data showed not a dawn, but an explosion. The telescope studied the epoch of reionization, the critical age when ultraviolet radiation from the first stars and galaxies cleared the fog of neutral hydrogen that enveloped the universe. And what it found was this. This process was much faster and much more violent than expected. The first galaxies were pumping out ionizing radiation at levels many times higher than models predicted. The lights of the universe turned on at a record speed, as if someone had pressed all the buttons at once. This meant that those first galaxies were not just large, but also hyperactive. Their star formation engines were running in top gear before they had even finished their warm-up lap. How could this be possible? Where did this excess energy come from? Many scientists believe the answer lies again in those untimely supermassive black holes. The brutal radiation from their accretion disks could have cut through the universe's fog like a laser. But even this creates a chicken and egg problem. Which came first? The monster black holes that illuminated the universe so quickly, or the already hyperactive galaxies that allowed these monster black holes to form? This discovery completely rewrote the story of one of the most formative moments of the universe. The dawn did not break slowly. The door was kicked open. Planet breathes. This is one of the biggest steps taken towards answering the question, are we alone? As you can see, every one of Webb's findings is the product of an incredible technological and scientific mechanism behind it. It has infrared eyes to capture the oldest light of the universe. It works at a temperature close to absolute zero to protect that light from its own heat. It carries an advanced spectroscopy laboratory to understand the chemistry of what it sees, and to see the faintest objects. It uses the universe itself as a magnifying glass. When all these pieces come together, not just an observation tool, but an engine of discovery emerges, a machine designed to answer one question, but which instead created thousands of new ones. But all these technical details, these engineering marvels, bring us to the really exciting point. Equipped with these tools, Webb has come closer than any telescope before to one of the biggest and most fundamental mysteries of the universe, to an area where models have collapsed, theories have become insufficient, and the boundaries of science are being redrawn. What we have described so far were just individual discoveries, but next up is the great, unsettling inconsistency about the expansion of the universe itself, which all these discoveries point to. And this inconsistency could change everything. And now, we come to the moment where everything converges. All the techniques, all the engineering marvels we have described so far were just tools. Now it's time to see what those tools have found. Because the eyes. Webb turned to the edge of the universe didn't just find a few anomalies. They triggered a revolution. They created a cosmological earthquake. Get ready. Because the tempo is changing now. We are accelerating. What you've heard so far was just a whisper. Now you will hear the roar. Here are the moments that are shaking modern science to its foundations, rendering textbooks obsolete, and demolishing our most basic assumptions about the universe. This was not a galaxy. This was an impossibility. Its name is JADES-GS-Z-13-0. But that's just a code name. Its real meaning is this: one of the oldest, most distant galaxies ever seen. Its light travelled for more than 13.4 billion years to reach us. This means it shone when the universe was only 300 to 400 million years old after the Big Bang. This number is hard to grasp. So hard that if you condense the entire 13.8 billion year life of the universe into 1 year, this galaxy existed only in the first 3 days of the year, and it shouldn't have been there. The model said that in that era, there could only be gas clouds and perhaps the first stars. But this was not a gas cloud. This was a fully formed structure, home to hundreds of millions of stars. The standard model has a rule known as the mass accumulation limit. This rule draws the theoretical limit of how large a galaxy can be at a certain time. This galaxy, and dozens of others like it that were found, shattered that limit. Some of them had 10 times, or even more, mass than was theoretically possible in that era. This was like a truck ignoring the speed limit sign of physics and going at 100 times that speed. This single discovery instantly made decades of galaxy formation theory suspect, because the universe was not the slow and patient builder we thought it was. It was an architect who built empires overnight, and we were completely blind to this fact. But at the center of these empires, an even bigger monster was hiding, and this was a contradiction with time itself. Webb looked at the oldest quasars in the universe, that is, galaxies being viciously fed by the supermassive black holes at their centers, and what it found there was, in the truest sense of the word, unbelievable. Black holes that existed when the universe was less than 600 million years old, only 4% of its current age, and these black holes were not tiny. Some of them exceeded 1 billion solar masses. This is more than a number. This is a paradox. Because, even with the most efficient known growth model, a black hole needs at least 1 billion years to reach this mass. But the universe itself was not yet that old. The mathematics of time did not add up. This was as impossible as a 4-year-old child having 80 years of life experience. This discovery was so shocking that even the most radical theories, like direct collapse black holes, struggled to explain it. Because Webb didn't just find one of these monsters. It showed that they were surprisingly common in the early universe. This was not an exception, but a norm. In the early period of the universe, somehow, a mechanism that surpassed the laws of physics had created these gravitational monsters at a record speed. And we do not know what this mechanism is. This means there is a huge black hole in our most fundamental knowledge about the beginning of the A. And then, Webb shed light on the biggest crime scene in the universe, the Hubble tension. For years, it was the biggest and most embarrassing problem in cosmology. We have 2 main methods for measuring how fast the universe is expanding. The first measures by looking at the nearby universe, using standard candles like supernovae. The second looks at the cosmic microwave background, the oldest light left over from the Big Bang, and calculates the current expansion rate from the initial conditions of the universe. And for years, these 2 methods have stubbornly given different results. The difference was not a small rounding error, a full 8 to 10% discrepancy. Many scientists hoped this was due to measurement errors in older telescopes. They thought Webb's ultra-sensitive eyes would solve this problem. But Webb looked, and it did not solve the problem. It made it worse. Webb redid the measurements of the nearby universe with the highest precision in history, and it confirmed the results. The tension was real. It was not a measurement error. This was like a bomb exploding. Because this could mean one of 2 things. Either our understanding of the physics at the very beginning of the universe is fundamentally wrong, or there is a new component in the physics of the nearby universe that we do not know about. Webb destroyed a hope and replaced it with a much bigger crisis. Our most fundamental knowledge about the expansion of the universe was contradicting itself. And at the center of this contradiction lies the most mysterious and dominant force in the universe. Because this tension led us to the most epic and terrifying discovery: dark energy, the mysterious repulsive force that makes up 68% of the universe and accelerates its expansion. For decades, the standard model assumed that dark energy was a cosmological constant, that is, a constant force that never changes in time and space. It was a monotonous, unchanging note playing in the background of the universe. This simplified the equations. But in 2024, Webb's data was combined with data from other major surveys like DESI, and the result shook the world of cosmology. The data suggested that dark energy might not be constant. On the contrary, they presented the first serious statistical evidence that its strength might be changing over time. This is not just a technical detail. This is a discovery that rewrites the ultimate fate of the universe. Because if dark energy is weakening, gravity might one day win again and the universe could collapse in on itself. But if it is strengthening, then a much more terrifying end awaits us: the Big Rip. In this scenario, the expansion of the universe accelerates so much that it first tears apart galaxy clusters, then it tears apart the galaxies themselves, then star systems, planets, and finally individual atoms, ripping the very fabric of space-time. Webb did not remove this terrifying possibility from the table. On the contrary, by questioning our most basic assumption, it brought it to the forefront for the first time so seriously. So there you have it, the oldest galaxies in history. Black holes that grow faster than time itself, an expansion rate at war with itself, and a changing dark force that could tear everything down to its atoms. These four discoveries are not just puzzle pieces, this is the death notice of the old paradigm. So what is the meaning of all this chaos? Are these different crises actually different faces of one big, yet ununderstood picture? And what does this picture tell us about the fabric of the universe? And this picture tells us this about the larger scale architecture of the universe. The master plan is wrong. Because these anomalies found by Webb were coming together to form even larger, even more impossible structures. And this pointed to a much more fundamental problem than a single galaxy or black hole. This was about the moment of cosmic dawn itself, the moment the universe turned on its first lights, moving from darkness to light. Models predicted this transition to be a slow, gradual process that took hundreds of millions of years, like the slow breaking of a dawn. But Webb's data showed not a dawn, but an explosion. The telescope studied the epoch of reionization, the critical age when ultraviolet radiation from the first stars and galaxies cleared the fog of neutral hydrogen that enveloped the universe. And what it found was this. This process was much faster and much more violent than expected. The first galaxies were pumping out ionizing radiation at levels many times higher than models predicted. The lights of the universe turned on at a record speed, as if someone had pressed all the buttons at once. This meant that those first galaxies were not just large, but also hyperactive. Their star formation engines were running in top gear before they had even finished their warm-up lap. How could this be possible? Where did this excess energy come from? Many scientists believe the answer lies again in those untimely supermassive black holes. The brutal radiation from their accretion disks could have cut through the universe's fog like a laser. But even this creates a chicken and egg problem. Which came first? The monster black holes that illuminated the universe so quickly, or the already hyperactive galaxies that allowed these monster black holes to form? This discovery completely rewrote the story of one of the most formative moments of the universe. The dawn did not break slowly. The door was kicked open. But then, Webb made one of its most incredible discoveries. It saw a ghost, a single star. But this was not just any star. This was the most distant, most ancient individual star ever seen. Its name is Earendel, from an old word meaning morning star, and the name suits it well. Because Earendel's light travelled for a full 12.9 billion years to reach us, when it shone, the universe was only 7% of its current age. There were still billions of years before the sun was born. The Earth was still a cloud of dust. Seeing a single star at this distance is normally beyond impossible. It's like trying to see a single flashlight on the moon. But Webb used a trick the universe offered it. A massive galaxy cluster standing between us and Earendel magnified its light thousands of times through gravitational lensing, making the impossible possible. And when Webb analysed Earendel's light, it revealed another secret. This star was an incredibly massive and hot blue supergiant. But most importantly, it was not a population 3 star. That is, it was not from that first, legendary generation of stars made only of hydrogen and helium. In its spectrum, there were traces, albeit faint, of heavy elements. Do you know what this means? It means that before the universe was even 1 billion years old, the gas cloud from which Earendel was born was already enriched with the ashes of at least one previous generation of stars. Even in the earliest times of the universe, we were already in the second act. The first act had begun and ended so quickly that only its ghost remained. Earendel was the living test, or rather, the dead proof of how brutally fast a start the universe had. And this fast start was not limited to exotic and distant objects. It also included something surprisingly familiar: spiral galaxies, just like our home, the Milky Way. Models used to say that the formation of such regular, disc-shaped, calm galaxies required a process of evolution, mergers, and settling that took billions of years. In the chaotic environment of the early universe, filled with constant collisions, it was seen as impossible for such a delicate disk structure to survive. But Webb looked, and it found them, in large numbers, fully formed, thin-disked, regularly rotating spiral galaxies that existed when the universe was less than 2 billion years old. This was like finding a perfectly preserved porcelain plate, without a single scratch, in the middle of a battlefield. The existence of these galaxies demolished one of the most fundamental pillars of the standard galaxy formation model. We now know that a galaxy did not need billions of years to achieve a regular and calm structure like the Milky Way. Somehow, even in that most turbulent period of the universe, it had found a way to create and preserve these islands of order. This means that the conditions necessary for a star system like ours, a star like the Sun, and a planet like Earth to form, emerged billions of years earlier in the history of the universe than we thought. The window for habitable galaxies opened much, much earlier. All these discoveries, these broken records, these demolished theories, come together to form one single, massive picture. The oldest galaxies in history, black holes growing faster than time itself, an expansion rate in conflict with itself, a variable dark energy, a cosmic dawn like an explosion, and calm spiral galaxies standing in the middle of a battlefield. This is no longer just a few outlier data points. This is a systematic rebellion, the universe's revolt against the laws we wrote for it. This is forcing scientists to ask the most fundamental question. Maybe the problem is not with the models. Maybe the problem is with our most basic assumption itself, the age of the universe. But let's pause for a moment. Let's step back from this data bombardment, these records and broken theories. After running at this maximum speed, it's time to catch our breath and think. Because does all this cosmic drama, this chaos billions of light years away, have any meaning for us? For us living on this small, pale blue dot? And how do all these findings change the deepest philosophical questions about our place in the universe? And now it is time to stop and think. Let's step away for a moment from this ocean of data, these broken records, and cosmic crises. Because every photon Webb sends us, every shocking discovery, says something not only about the universe, but also about ourselves. Within this immense, violent, and mind-bogglingly ancient universe, who are we? In the midst of all this chaos, where is our place? So far we have asked the questions of what and how. Now it is time to face the most fundamental and most personal question. What does all this mean for us? Because The first and most jarring truth Webb shows us is a paradox of scale. On one hand, there is the most complex, most sensitive, and most powerful eye ever built by humanity. A technological marvel 1 million miles from Earth at a temperature close to absolute zero, capable of seeing 13.4 billion years into the past. This eye is a product of our intellect, our curiosity, and thousands of years of accumulated knowledge. This is the pinnacle of our power to understand the universe. But on the other hand, there is the universe itself, which that eye shows us, so vast that it would take us millions of years to reach even the nearest neighboring galaxy, so ancient that its history is hundreds of thousands of times longer than the existence of our species, and so full that a piece of sky the size of a grain of sand held at arm's length hides thousands of galaxies, hundreds of billions of worlds. How can such small and fragile beings comprehend something so immense? Herein lies the tragic side of this paradox, our physical insignificance. We will never go to those galaxies we see. We will never touch those ancient stars. They are unreachable ghosts, forever separated from us in the ocean of time and space. We are spectators standing on the shore of the universe who can never set sail. But, and that but changes everything, because although we cannot physically go there, we are there with our minds. Webb is our extension. It is the embodiment of our curiosity. With those eyes, we touch the light from 13.4 billion years ago. By deciphering the chemical secrets of those galaxies, we listen to their stories. Their inaccessibility does not make them incomprehensible. And this, perhaps, is the most beautiful truth. Our bodies may be chained to this planet, but our minds are free to travel to the dawn of the universe. You too are standing in the middle of this paradox. You too possess this incredible power. With a brain weighing only a few pounds, you can grasp a reality billions of light years away. This is your greatest tragedy, and at the same time, your greatest miracle. And this paradox of scale leads us to another, deeper paradox of time. On one hand, there is that dizzying depth of time that Webb shows us. The universe has existed for 13.8 billion years. Some galaxies were born, lived and died billions of years before our sun was born. The light we see left its source when this planet was still a cloud of gas and dust. The story of the universe is like an almost infinitely long epic. On the other hand, there is our own existence. Human history is not even the last letter of the last word of this epic. An average human lifespan, about 80 years, corresponds to a moment shorter than 1,000th of a second when compared to the age of the universe. We are a blink of an eye in this cosmic ocean. This is the melancholic truth. All these immense events, galaxy wars, star births, the dance of black holes, went on for billions of years without us, and they will continue for billions of years after we are gone. In this huge theatre, our role is so short that it is almost non-existent. This creates an existential vertigo. But there is a beautiful side to this story too, because that fleeting moment could be the moment that changes everything. It is the moment when the universe, for the first time, looked at itself. For billions of years, the universe existed blindly. It expanded unconsciously, but then, on this small planet, for that fleeting moment, we emerged, and for the first time, the universe became aware of its own beauty, its own tragedy, its own mystery. We are the universe's way of understanding itself. Our brief moment is not a meaningless void. It may be the only moment that gives meaning to this epic. You are a part of that moment. Your existence is the culmination of this billion-year story, because you are not just the one reading this story, but also the hero who becomes conscious of it. Your life, as short as the blink of an eye, is the most meaningful moment of the universe. This brings us to the most fundamental question. In all this greatness, how alone are we? There is one truth that Webb shows us. The universe is full of planets. In our galaxy alone, there are hundreds of billions of stars and probably even more planets. And there are hundreds of billions more galaxies like ours in the universe. The numbers almost shout that life must exist elsewhere. But on the other hand, there is that immense emptiness. Even the nearest star system is tens of thousands of years away with our fastest spacecraft. The voids between galaxies are so vast that it takes even light millions of years to cross. This is a cosmic quarantine. the unsettling silence of the Fermi paradox. This is a tragic possibility. Perhaps the universe is teeming with life, but due to the ruthless tyranny of distance, we are each eternally trapped on our own cosmic island, like fires lit on different shores of an ocean, never to see each other, never to know of each other's existence. This could be the universe's greatest irony. You have billions of neighbors, yet you are completely alone. But this silence may have another meaning. Perhaps this silence is not a void, but an invitation. Perhaps these distances are a test to be overcome. That faint chemical signal Webb found in the atmosphere of K218b was perhaps the first smoke signal from across the ocean. To understand that signal, to respond to it, is now our responsibility. This is a beautiful possibility. We are not alone. We just haven't learned how to find each other yet. You too can be a voice in this great silence. Your curiosity, your science, is an effort to send a message in a bottle across the ocean. Perhaps we are the generation that will send that message. Perhaps we will be the one to receive the answer. This silence may not be an end, but a beginning. These paradoxes, small yet understanding, fleeting yet meaningful, alone yet searching, are the fundamental pillars of the new picture of the universe that Webb presents to us. They are not just astronomical facts, but also our existential coordinates. But in drawing these coordinates, Webb revealed something else. Not just what the universe is, but also what it is becoming. And this leaves us with the deepest and most unsettling questions about the future. And this question of the future brings us to perhaps the most unsettling paradox, a paradox of knowledge and fate. On one hand, there is the incredible power of information that Webb offers us. We can decipher the oldest secrets of the universe, read the chemistry of 13 billion years ago, and analyze the atmospheres of planets orbiting other stars. Our knowledge is deeper than ever before. Our ability to understand the rules of the universe is at a level our ancestors could not even have dreamed of. We are the beings who are cracking the code of the universe, but on the other hand, there is the fate that this code tells us, and that fate is completely beyond our control. The data from Webb and other telescopes show that the expansion of the universe is not only continuing, but also accelerating, and dark energy, the force behind this acceleration, will determine the ultimate end of the universe. This is the most tragic truth. The more we learn, the more we understand, the better we realize how powerless we actually are. We are spectators who can read the final act of the universe in the finest detail, but can do nothing to change the script. If dark energy remains constant, the heat death of the universe awaits us in billions of years, a cold, dark void where everything moves away from everything else, and the last star dies. If it strengthens, a violent end with the Big Rip awaits, where everything is torn apart down to its atoms. As our knowledge increases, so does our awareness of our helplessness. But there is a beauty even in this helplessness, because knowing, understanding, even if it cannot change our destiny, can give it meaning. We cannot escape that end, but we can bear witness to it. Knowing the end of this immense story of the universe makes our own place in that story more valuable. It is like watching a play whose ending you already know. This knowledge does not make the play less enjoyable. On the contrary, it makes every moment, every dialogue, more meaningful. We are the first and perhaps the only witnesses who know the universe's own end, and this places a unique responsibility on us. You are the heir to this knowledge. You know the fate of the universe. This knowledge may frighten you, but it can also give you strength, the strength to understand the value of your own fleeting moment, that priceless moment in this vast cosmic drama. And what if this knowledge, this effort to understand, is just an anomaly? Or is it something inherent in the nature of the universe? This leads us to a paradox of order and chaos. The universe Webb shows us is incredibly chaotic and violent. Galaxies collide, black holes swallow everything, stars explode. The first moments of the universe were much more savage, much more disorderly than models predicted. Everywhere there are impossible objects that break the rules, that subvert expectations. This suggests that the fundamental nature of the universe is chaos, a random, unpredictable, and ruthless place. But on the other hand, there is the incredible order that emerges from that chaos. In the middle of that battlefield, a calm, spiral galaxy like our Milky Way can form. Within that galaxy, a stable star like the Sun can burn for billions of years, and in the orbit of that star, a planet like Earth can give rise to that most delicate, most complex form of life. And from that life, you, a consciousness capable of understanding this chaos, of giving it meaning, emerges. How can the most profound order arise from the most extreme chaos? This is the most melancholic truth. This order is perhaps an incredibly rare exception in the universe at large. Perhaps we are a tiny, lonely island of order in an ocean of chaos. And this island is in constant danger of being swallowed by the waves of that ocean. But this rarity is also the most beautiful truth, because it makes us special. It makes us precious. If order were the norm, it would be ordinary. But its existence as an anomaly within chaos gives it a priceless meaning. Every breath, every thought, is a victory won against the fundamental tendency of the universe. We are a rebellion against chaos. You are a part of that rebellion. Your existence is proof not of the most likely outcome of the universe, but of its most miraculous exception. Your consciousness is a beacon of order shining in the midst of chaos. And this search for order brings us to a final paradox, a paradox of certainty and uncertainty. On one hand, there is the incredible certainty that Webb provides us. We can measure the distance of a galaxy with an error margin of a few million light-years. We can count the molecules in a planet's atmosphere one by one. Our data is so precise that even an 8% discrepancy in the expansion rate of the universe can throw us into a crisis. Science is built on certainty, observation, data, evidence. But on the other hand, there is the absolute uncertainty that this search for certainty leads us to. The more we learn, the more data we collect, the better we understand how little we actually know. Every answer gives birth to 10 new questions. We found impossible galaxies, but we don't know how they formed. We saw untimely black holes, but we don't know how they grew. We proved the existence of dark energy, but we don't know what it is. This is the most tragic irony. As we climb to the peak of knowledge, we see how vast the ocean of ignorance that lies before us is. Every discovery, instead of expanding our horizon, actually draws the boundaries of our ignorance more clearly. But this uncertainty is also the most beautiful and driving force of science. If we knew everything, if everything were certain, there would be nothing left to search for. Curiosity would die, discovery would end. What pushes us forward is not what we know, but what we do not know. That ocean of uncertainty is not a sea of fear, but a sea of possibilities. Every question mark is the beginning of a new adventure. You are an explorer in this adventure. Your questions, your curiosity, are a ship searching for new islands in that ocean. You may not find all the answers, but the search itself, the journey itself, is what gives meaning to your existence. These are the deep truths that Webb whispers to us. We are both nothing and everything in this universe. We are both a moment and a witness to eternity. We are both alone and part of a universal connection. We are beings who witness our destiny with our knowledge, an order born from chaos, facing uncertainty in the search for certainty. We now know how strange, how unexpected the universe is. We now understand how paradoxical our own place is. But after all we have learned, one more question remains unanswered. Perhaps the most important one. Were the rules of this whole cosmic game what we thought they were from the very beginning? Or is even the Big Bang itself just one chapter of the story? And this question brings us to the most fundamental and unsettling inquiry. Because if even the Big Bang is just one chapter of the story, then there may be no such thing as a beginning as we understand it. This thought shakes not only our astronomical models, but also our deepest intuitions about time and existence. It is time to question not only what the universe is, but also what our very act of knowing means. This is the final layer of philosophy. What do we do with this knowledge? The first thing we must confront is a paradox of model and reality. On one hand, there are the models created by the incredible power of the human mind. The standard model of cosmology, like Lambda-CDM, was an elegant mathematical masterpiece that explained the universe with incredible precision for decades. It was the best map we had to understand the universe. These models are proof of our effort to bring order to the universe, to make chaos comprehensible. We are beings who tell stories, search for patterns, and try to fit everything into a framework. But on the other hand, there is the raw, unfiltered, ruthless reality that Webb shows us. That reality does not fit our models. It does not fit within the boundaries we have drawn. It is full of impossible objects that our elegant equations did not predict. This is a tragic awakening. The moment we realize that the map we trusted most is not in fact the terrain itself. The moment we understand that this map has led us to the wrong places, that it failed to show important mountains and oceans. This is a feeling of intellectual orphanhood. To see that the fatherly model that guided us did not actually know everything, that it was even wrong on fundamental issues, creates a scientific insecurity. But this is also an incredibly liberating and beautiful moment, because the map is not more important than the terrain. The breaking of a model is not a failure, but progress. It is the moment we realize the room is much bigger than we thought. It is proof that the universe is more creative, more strange, and more magnificent than our imagination, than our mathematics. Webb did not just present us with new data, it taught us humility anew. You too use your own models, your own maps in your life. You have beliefs, assumptions about the world, about yourself, about other people, and sometimes life shows you that your map is wrong. That moment is painful, but it is also the moment when growth, learning, and getting one step closer to the truth begins. The crisis that science is experiencing is a cosmic reflection of your personal journey. This situation leads us to another, more personal paradox, a paradox of curiosity and answers. The most fundamental force that drives us forward as a human species is curiosity. That endless journey that began when the first human looked at the night sky and asked, "What are those shining dots?" The Webb Telescope is the latest and most magnificent monument to this curiosity, a multi-billion-dollar project. Decades in the making, built solely to answer the question, what is out there? Our curiosity is an engine that carries us beyond our planet, that takes us to the dawn of the universe. But on the other hand, there is the truth that Webb offers us. Every answer gives birth to questions that are much larger and much more fundamental. We found the oldest galaxies in the universe, but now we have to ask, how did they form so fast? We confirmed the existence of dark energy, but now we have to ask, what is it really? This is a tragic quest. Like a traveler chasing a mirage in a desert, every answer we reach creates a new horizon, a new mirage of questions. To see that answers do not bring ultimate satisfaction, but instead create a greater sense of not knowing, can create a kind of intellectual fatigue, as if no matter how much we run, we will never reach the destination. But the beauty of this quest lies exactly here, because what is truly important is not finding the answers, but continuing to ask the questions. Curiosity is not a destination, but a journey itself. The greatest gift the universe offers us is not a final answer, but an eternal mystery. This mystery keeps us alive, it unites us, it pushes us to learn more, to look further. You were born with this curiosity. The why, questions you asked as a child, are the same cosmic curiosity that built Webb. You will never find all the answers, but this is not a curse, it is a blessing. Because it means that throughout your life, there will be new things to discover, to learn, and to marvel at. Your curiosity is the strongest bond that connects you to the universe. So where does this bond, this universal curiosity, take us? This brings us to a final paradox, a paradox of destruction and creation. Every discovery Webb has made has destroyed an old idea, an old model, an old certainty. The standard model of cosmology was one of the most solid fortresses of science for decades. Webb has delivered blow after blow to the walls of that fortress. The crisis of faith, experienced by scientists like Allison Kirkpatrick, is an indicator of how personal and deep this destruction is. To see an idea you have dedicated a lifetime to being shaken by new evidence is painful and frightening. This is a kind of scientific grieving process, the death of the universe you knew and trusted. This is the tragic face of destruction. But every destruction is also the birth pang of a new creation. The collapse of a model is not the end of science, but the beginning of a new science. Upon these ruins, a new model will be built, one that explains the universe better, that is more inclusive, more accurate. This crisis is not an end, but a renaissance. Just as Newtonian physics was destroyed but also surpassed by Einstein's theory of relativity. just as the Earth-centered view of the universe was raised by the Copernican revolution. To advance, science must destroy its own heroes, its own most beloved ideas. This is its most ruthless, but also its most beautiful feature. You experience this cycle in your own life. To grow, you must destroy your old self, your old beliefs, your old habits. Every loss opens up space for a new beginning. Every crisis is an opportunity to create a stronger, wiser you. The painful rebirth that cosmology is currently experiencing is a universal truth that resonates in all our lives. This is the deepest lesson Webb has taught us. Reality is greater than our models, mystery is more valuable than answers, and destruction is an indispensable part of creation. When we understand these lessons, we begin to understand not only the universe, but also ourselves better. But after all this inner journey, one question still remains unanswered. When we turn our eyes outward again, to that infinite darkness, what do we see with this new understanding? And how does this new perspective confront us with one of the greatest mysteries of the universe? And this new perspective confronts us with the most fundamental dynamic of our relationship with the universe. What we see now is not just a series of physical objects. It is a mirror reflecting the limits of our own understanding, our own existential drama. This is the final philosophical stop on our journey. Because with this new map of the universe, we must look not only outward, but also inward, to the nature of our own consciousness. This brings us to a paradox of vision and blindness. On one hand, there is the unprecedented field of view that Webb offers us. We see the dawn of the universe, the first few 100 million years of a 13.8 billion year history, with a clarity that was previously unimaginable. The past has become an almost crystal clear landscape for us. We can read the birth certificate of the universe. This is one of the greatest triumphs of the human mind. We are beings who can see the past, but on the other hand, there is the blindness created by this sharp vision. Because the more clearly we see the past, the more we understand how uncertain and beyond our control the future is. The findings about dark energy, in particular, have put all scenarios for the future of the universe, heat death, big rip, on the table. This is a tragic truth. We have to face the absolute uncertainty of the future while possessing the immutable, fixed knowledge of the past. We have a perfect map of the past, but the road ahead is completely shrouded in fog. It is like looking at the universe through a car's rearview mirror, which shows the landscape behind perfectly, but prevents you from seeing what's ahead. This knowledge can create a kind of fatalism, a feeling of helplessness. But this also offers us a priceless gift, because the past is fixed, but the future is full of possibilities. We cannot control that future, but we can live in the present moment. We understand the value of existing in this golden age of the universe. This brief cosmic interval where we can both see the past and the future has not yet destroyed us. This uncertainty is not a curse, but a grace that reminds us of the sanctity of the present moment. You live within this paradox too. The memories of your past are clear, but the uncertainty of your future is always there. This cosmic truth is your most personal truth, and the art of living with this uncertainty is the art of living wisely itself. So what is the value of this present moment? This leads us to a paradox of connection and separation. One of the most beautiful pictures Webb has shown us is that vast cosmic web, a universal structure where galaxies are connected along filaments, an image that whispers that nothing is alone, that everything is part of a larger whole. Our galaxy is just a dot on one of those filaments. That web is our universal family, our cosmic family tree. We belong to this huge, interconnected structure. But on the other hand, there is the ruthless truth caused by the same physics, namely dark energy. This web is tearing apart. As the expansion accelerates, galaxies are moving away from each other, and one day the vast majority of the galaxies we can see now will pass beyond the cosmic horizon. Their light will never reach us again. They will disappear from view. This is a tragic fate. Just as we fully understand that we belong to a universal family, we learn that this family is doomed to break apart. We are part of a fabric that is slowly unraveling, coming apart. This is a cosmic reflection of the farewell that each of us will eventually experience. But, despite this inevitable end, that connection is real right now. In this moment, the light that set out from those distant galaxies billions of years ago is reaching your eye. My eye, right now. We have the privilege of living in an era when the universe is at its richest, most connected. Perhaps future civilizations will look up at the sky and see only their own galaxy, completely unaware of the rest of the universe. We are the last witnesses. We are the ones living in that last family photo where everyone is together, and this makes witnessing that moment even more precious. You're inside this truth too. The bonds in your life, your loved ones, your family, they are all temporary, but this does not diminish their value. On the contrary, it increases it. To appreciate the value of those bonds is to understand this cosmic truth. And this understanding, this witnessing, ultimately leaves us with one emotion. After this long journey, after this adventure that stretched from the dawn of the universe to the darkness of the future, how do you feel? On one hand, is there that deep awe and wonder you feel in the face of that unimaginable vastness, those billions of galaxies, that 13.8 billion year history? Do you see yourself as part of this magnificent symphony, enriched by this knowledge? Or on the other hand, is there that feeling of overwhelming smallness, that fragility, that meaninglessness you feel in the face of that same vastness? Does it scare you a little, make you feel a little lonely, to see all the models we trusted crumble, to see how incomplete everything we thought we knew actually is? The truth is, both feelings are completely valid, and both are correct. Because just to be human is to oscillate between the two. We are both magnificent beings made of stardust and specks lost in this infinite void. Perhaps the greatest lesson Webb has taught us is this: awe and humility are two sides of the same coin, and true wisdom is to be able to carry both of these emotions in your heart at the same time. This is where we have arrived at the end of this long philosophical journey. We now know that our place in the universe is full of paradoxes. We are the ones who see the past but are blind to the future. We are part of a web that is connected but doomed to separate. We are the ones living through the battle between our models and reality. We are the ones who find more questions than answers with our curiosity. And we are the ones who learn that every destruction is a new creation. This is the new wisdom that Webb offers us. This is the cosmological worldview of the 21st century. This long and deep journey has taken us from the farthest corners of the universe and brought us, in the end, into ourselves, to the center of our own consciousness. Now it's time to take all this knowledge, all this philosophy with us, to wrap things up one last time, and to summarize what we have learned from this incredible adventure. And for this reason, the place we have arrived at the end of this long journey is a starting point. On this journey, we went to the farthest corners of the universe, to the dawn of time. We met galaxies that shouldn't exist. We witnessed black holes growing faster than time itself. We saw how the most fundamental models of cosmology were shaken, how the maps we trusted most became invalid, and in the end, we questioned our own place, our own paradoxes, in the midst of this cosmic drama. This was not just the story of a telescope. This was the story of human curiosity, of that unwavering quest that does not give up even when faced with its own smallness. We now know that the first few 100 million years of the universe were not a calm beginning as we thought. It was a roar. It was an era where galaxies 10 times larger than the standard model allowed existed when the universe had completed only 2% of its 13.8 billion year life. This is not just an anomaly. It is the universe's way of telling us the story you are telling is wrong. And this fact forces us to rethink everything, even the age of the universe. Webb didn't just open a new window for us, it woke us up to a completely new universe. You are a part of this new universe. This knowledge, this uncertainty, this awe, and this humility are now your heritage too. You now know better how strange, how complex, and how miraculous the universe is. And this knowledge might make you feel less alone when you look into that infinite darkness, because you are a part of the universe's effort to understand itself. If this journey has also made you feel that deep sense of admiration and curiosity for the universe, subscribe and share your thoughts with us to continue these discoveries. Because this story is all of our story, And these mature galaxies, this early chemical enrichment that Webb has shown us, brings us even closer to those first moments where it all began. Because all these structures are a result of the fundamental rules set in those first moments. But what happened in the first few minutes when those rules were written? On this journey, we looked at the first hundreds of millions of years of the universe. But I didn't tell you something. The real revolution happened in the first 3 minutes. The fate of everything was decided in those 180 seconds. The most basic elements like hydrogen and helium were born at that moment. What about the others? Why weren't they formed? On our next journey, we're going to those first 180 seconds after the Big Bang. Are you ready?